Now that we looked at the natural log of x, I want to shift our focus a little bit to the number e. And how is it defined? Well, ln e is defined as the integral from 1 to e of 1 over t dt such that this integral is equal to 1. Remember, we said ln x equals the integral from 1 to x of 1 over t dt. So that's the definition of ln x for some arbitrary x. Now, what this is saying is that if I take a look at what this function looks like, 1 over t, 1 over t will look like this. And asymptotically, it'll go to 0. So here's the t-axis. And when t equals 1, I'm up here at 1. So what it's saying is I'm going to take the integral, I'm going to integrate to some value of x such that when I take that integral, this area under the curve is equal to 1. So that's the total area under the curve between 1 and x. I'm going to stop at the x that gives me 1. Well, that x is, in fact, that magic number e. And that's what this is saying here. I'm going to integrate from 1 to e of 1 over t dt such that the total area under the curve, this total area, is equal to 1. And what does it is when x is equal to, well, approximately 2.718, and that is the value of e. So if I go from 1 to 2.718, and it goes on and on and on, just like pi, e goes on and on forever and never repeats. I can approximate it though roughly as 2.718. So if I take the integral from 1 to 2.718 of 1 over t dt, this is actually going to give me 1. And this is right there, that value e. Now you've already seen another representation of e in terms of a limit. One of the representations you've seen before is if I take the limit as x goes to infinity of 1 plus 1 over x raised to the x, that is also e to the first power, which is obviously just e. So this gives me the same number as this integral. Well, actually, the integral doesn't give me e. If I integrate 2e, I get 1. And this is how I define ln e. So ln e, if you didn't catch it already, the natural log of e is actually equal to 1, which makes total sense if I'm going to digress for just a moment here in terms of logarithms. Ln e, or ln, is the same as log base e. So this ln e is log base e of e, and that equals some value, I'm going to say k. Well, by the definition of logarithms, this can happen if and only if e to the k equals e. And that can only happen if and only if k equals 1. So there's a real quick reminder of what the definition of a logarithm is, just in case you kind of forgot. Now, if I let f of x equal ln x, then f inverse of x, the inverse of ln x, is e to the x. So the natural log and e to the x are inverses of each other, which you can see if you graph them. If you graph e to the x, it looks like this, where this is at 1. And if you graph ln x, it looks like this, where this is at 1. And one of the definitions graphically for inverse functions, or one of the properties of inverse functions, is that they are symmetric with respect to the line y equals x. And clearly, if you graph these like a maple or something, which you should do, these are definitely symmetric about the line y equals x. So ln x and e to the x are in fact inverses of each other. So let's just do a very quick algebra review on how we commonly use logs. If I need to solve 3 equals e to the x minus 2, I need to have a way to get at this exponent. I can't just solve it as it sits. And the way we do that is because this exponential function is base e, is we'll use the natural log. So this implies then that the natural log of 3 is equal to the natural log of e to the x minus 2. Now the natural log of 3 is a number. And with the properties of logs, I can take the exponent now and pull it down in front. So that tells me that natural log of 3 is equal to x minus 2 times the natural log of e. But we already said the natural log of e is 1. So that is just simply 1. So what this is really telling me is that natural log of 3 must be equal to x minus 2, which implies that x must be equal to ln 3 plus 2. So this is the exact answer. If you need an approximation, you can go to your calculator and get ln 3 and add 2 to it. So if I substitute this in for x, I will get 3 equals e to the ln 3 plus 2. There's my x minus 2, so those are going to go away. So 3 is equal to e to ln 3, which that's an implication, which is true. E to ln 3 is in fact 3. Matter of fact, x is equal to e ln x. That's the true statement. Now, e to the x is called the natural exponential function. Obviously, e to the x is an exponential function, just like 4 to the x is an exponential function. But with base e, we refer to it as the natural exponential function.